In this video, we want to take a look at using polynomial functions or equations to solve application problems. Specifically, we are looking for the dimensions of a box given certain criteria. My first example has the length, width, and height being consecutive whole numbers and a volume of 120 cubic inches. A few assumed facts. First, that I remember that volume is length times width times height. And next, that I know the consecutive means one right after the other, like 1, 2, 3. So, knowing that, I can set up the equation 120 for the volume is equal to x, my first unknown dimension, and then the next one would be x plus 1 because it's consecutive, and the third one would be x plus 2 because it's the one right after that. Then we'll go ahead and simplify that and bring everything over to one side. Now, rather than try to solve this algebraically, we're going to put it into our calculator and find the zeros. All right, so let me see if I can get that to go away. There we go. I put in my equation and then I graphed it. And again, what I'm looking for is where does this function's value equal 0, which means the y value is 0, which means I'm looking for the x-intercept. Now they've told me it was a whole number, so I should be able to look at that and guess what that number is. So it looked like 1, 2, 3, 4, and sure enough, it was 4 that makes this equal to 0. You don't necessarily have to change your window for these, but on this one, I knew that my x values had to be positive, so 0 to 10, and I know that my volume goes up to 120, so I did adjust it just so I could see. The point is, though, you're looking for the x at the x-intercept, in this case 4, and then I say, well, my other dimensions were x plus 1 and x plus 2, so substituting the 4 in for x, we come up with the dimensions of 4 by 5 by 6. Have a similar one here. This time we're told that the dimensions of the box, we have 3 times the height, or I'm sorry, the length is 3 times the height, and the height is 1 inch less than the width, and then we're also given the volume of 240 cubic inches. Okay, so I have to try to figure out what should be the unknown here. Length is given in terms of height, so maybe it's height, but then I keep reading and it says height is given in terms of width. So you want to use the best reference, so I'm going to say W will be the width, and then I can define the height in terms of that, so 1 less would be W minus 1, and the length is 3 times that, so 3 times the quantity of W minus 1. Once again, we'll use our formula of length times width times height. So 240 for the volume, and then the order that you put them in really doesn't matter. I just like to put my plain variable in front, so I put the W and then my other two values in here. And you notice I went ahead and distributed the 3 just because it would be easier to simplify. Working that out, foiling it, distributing, you should get this equation here. And I notice, well, wait a minute, they're all divisible by 3, so I can simplify it further and get this equation here. Now, in my calculator, I really don't have to do all that stuff, so let me go ahead and turn this on here and show you. If I were to just take the x, instead of a w of course, times the x minus 1, times the 3x minus 3, and minus 240, that's really sufficient. My calculator can multiply it out. So this stuff here that I did makes it look pretty, but it's really not necessary if you're just going for the answer. So on the window for this one, I also want to have my x's to be positive 0 to 10, but I'm told that my volume is 240, so I adjusted from negative 10 up to 240, and just so my y-axis is not too thick, I went ahead and changed the scale to 10. So when I look at the graph, I see this picture. Well, remember, the units on the x-axis were 1, so 1, 2, 3, 4. It looks like 5. If I hit trace and say 5, sure enough, it confirms my y is 0. So now I know what my x value is. I can go ahead and substitute in to the other dimensions and get my w minus 1 is going to be 4. And then my 3 times the w minus 1, well, that'd be a 4 times 3 would be 12. So the dimensions for this box would be 4, 5 by 4 by 12. Let me know if you have questions.